Hey guys, in today's Adventures in Super Fun Math, we're going to talk about something called normal distribution. You may have heard of like the bell curve. So you would say, oh, there's a bell curve for grading. You may not have heard of that. But anyway, one type of probability distribution, meaning like how likely is it that you score within a certain range or a certain thing happens around the mean. Like how likely is it that you're within 2 points of the average or 5 points of the average? So one type of probability distribution is normal distribution. And we're going to start this video off with some dog drinking. As always, it's so ridiculous. They lay around and sleep, and then when I make a video, they get up and make a bunch of noise. It's called the bell-shaped curve, like I said, and it's symmetric around the mean. So it's like a little hill of data, and the mean is right here in the middle. A lot of times we call that X bar. And then it's showing that like it's symmetrical, same on both sides. So if this is the mean right down the middle, it's the same on both sides. And it looks like a little hill. So the total area under this curve is 1, representing 100% of the data and the probability of being within that curve. So if you can see on here, a normal distribution, with a mean of X bar, like I was saying, standard deviation of this little sigma. Here's what that means. Standard deviation is like how far away from the mean are you? So you'll see here that this is the mean plus 1 standard deviation. And then this is going to be the mean plus 2 standard deviations. And then this last part is the mean plus 3 standard deviations. And then there's a little tiny bit out here. Anything in this place is considered an outlier, meaning it's like pretty, like super duper unlikely to happen. Then same thing to the left. Here you're going down 1 standard deviation below the mean. So that's why you have X minus 1 standard deviation, then X minus 2 standard deviations, X minus 3 standard deviations. So you're going above and below the average. And you can see that the spacing is the same because once you figure out what the standard deviation is, meaning that measure, that's how far apart those lines are. So like pretend your average was 50 and your standard deviation was 2. This would be 52, 54, 56. Going left, it would be 2 before that, so 48, 46, 44. So it's just showing like all of your data would kind of end up in between 44 and 56 if it's normally distributed. And most of your data would be up here at like the top of the hill because it's got the most stuff under it, because you're looking at this and saying, look at the majority of my data's in that space between 1 standard deviation below and 1 standard deviation above the mean. So out of fear of that all being very complicated, we're going to work on this for 2 days. And today we're just going to concentrate on these chunks going to the right and left from that mean, which is smack dab down the middle. So right here is X bar. So you can see from this chart that about 68%, when it's normally distributed, 68% of the data, meaning the area under that curve, is within 1 standard deviation, meaning 1 to the right or 1 to the left. And that's why this is showing 68%. So basically you end up with 34 on each side because, and that's where this is over here, showing you each side is 34. So obviously when you put them together, you get the 68 that's in the first picture. Okay, then it says about blank percent is within 2 standard deviations. So now you're looking from 2 below to 2 above, and you can see in the picture here that that's showing 95%. And so here, from this 2 below to 2 above is still 95%, but 68 of it was in here. When you take away the 68 and then divide what's left in half, each of these chunks separately is the 13.5. So if I added the 13.5, then the 34 of this chunk, then the 34 of this side, and then the 13.5 here, if I added those four chunks together, that would come up to be the 95 that the one on the left is showing. So it's just breaking it down into smaller sections over here. Okay, then the last one is saying how much of the data, how much of the area lies within 3 standard deviations. So here you'll see your 3 below, here you see your 3 above. So it's asking like how much is in this part. And the answer to that is 99.7. So just a little teeny smidge here and here is all that's beyond the 3s. And those are so unlikely because they have such a tiny little space under them that this is where you're going to find anything that's considered an outlier in a normal curve. So what does this look like in terms of like what you have to be able to do? So for today, you are just going to be identifying like how much of the curve are they describing. So in this first problem, you are finding the probability, meaning the area under this curve, because that's what this calculates, is the probability. So the probability is the area under the normal curve of something between the mean and x, the mean, minus 2 standard deviations. So find that. Here is x minus 2 standard deviations, and here is the mean. So they're asking you about these two pieces. So I'm going to go over here and say if this is x bar and this is x minus 2 standard deviations, meaning 2 to the left, this chunk they're telling me in that picture is 13.5. And then this chunk that gets me to x bar, which is what they're describing, is going to be another 34. So when I add them together, there's 47.5% probability of being in those two sections. So when you don't have like notability, it's not a terrible idea, and I'm always going to encourage you to draw a curve. It can be really kind of crappy, just like a hill, line down the middle. And then in this problem, you're going from dog fight, 2 to the left to the x bar. I swear it's always quiet here until this. Let me break up this fight also. If you watched the video yesterday, there was also a dog fight. So I'm going to be doing these two chunks. So I like to draw a picture before I start, which I didn't do, so I'll do that from now on. Now this one says, what's the probability that what you're looking for, meaning x, is greater than the average? Okay, well, in my curve, the average is right smack dab in the middle. So greater than would be everything to the right. Well, okay, if I added up everything to the right, I would end up adding 34 plus the next chunk, which is 13.5, plus the next chunk, which is 2.35, plus this little sliver, which is 0.15, and I would actually get 50%, which I probably don't really need to do all that work because now that I look at it, that is literally half. And if the whole thing's representing 100% of the data, then that top half would be 50%. So kind of however you get to that. All right, let's take a look at this last one on this page. You're now looking for the probability that x is less than or equal to this. Okay, well, let's find that on our curve. Here is x bar, 1 to the right and then 2 to the right. X plus 2 standard deviations is what they described, would be from here to here. Just going by what it says. Here's x bar, here's x plus 2 theta. Oh, actually, it's not between them even. It just says it's less than. So that is going to be everything less than that x plus 2 theta, or excuse me, x plus 2 standard deviations. So if I can erase my work from last time, they're looking for any x that's less than x plus 2 standard deviations, and less than would be this chunk, this chunk, this guy, this guy, this guy, this guy. Now, to make my life easy, keep in mind that from here on down is going to be half. So this is going to be 50% to get to here. So instead of doing chunks, I'm going to do that as 50. Then I'm going to add this one chunk to the right to get to 1 standard deviation. Then I'm going to add this next chunk to get to 2 standard deviations, which is 13.5. So when I do that, I just add them all up, I end up at 97.5%, which makes sense because if you look at my picture, the vast majority of it is colored in. The only part that's not is like this little smidge over here. So your answer should make sense. Like 50% makes sense because half of it's colored in. 47.5% makes sense because almost half is colored in. This little part over here is not. Okay, so these are just repeated so you have one to look at. Now, this one, they're going to give us a situation. Do not let this freak you out. So I'm going to draw myself a little curve. Doesn't even have to be good, which clearly mine is not. Here's the mean. 1, 2, 3 standard deviations to the right. 1, 2, 3 standard deviations to the left. So it's saying the blood cholesterol reading for a group of women are normally distributed with a mean of 172. So that means 172 is the value in the middle. Standard deviation of 14 means that as you go to the right, you add 14 for each chunk, and if you go to the left, you take away 14. So here at 1 standard deviation to the right, I'm going to add 14 to my 172, and that would be a reading of 186. Then I need to add 14 to get to my 2 standard deviations to the right. So if I take 186 and add 14, I'm at 200. And then to get to 3 standard deviations, I would add 14 and be at 214. So the numbers on the top are representing like the real life scenario. And then the numbers on the bottom match up with the standard deviations that are up here in my chart that I use to get my answers. Okay, if I went to the left, I would be 14 below 172, which would land me at 158 if I'm going to the left 1 standard deviation. One more drops it down by 14 again, and take it down by 14 again. So these are going to be the numbers that are in the situation, the blood cholesterol readings, but the numbers at the bottom are going to be the ones I can actually look up on my chart. So all I did on the top was this. I started with my X bar in the middle, my average, and I added 14 every time I went to the right a chunk, and I took away 14 every time I went to the left. Okay, but what percent of women have readings between 158 and 186? Well, 158, my friends, is -1 standard deviation, and 186 is +1 standard deviation. So it's asking me about these 2 chunks. Like literally my dogs drink so much water while I'm making these. So that's going to be that middle part where it's 34 here plus 34 here. And that's going to land me at 68%. Then it says readings higher than 200. So they're saying, hey, what's the probability that it's higher than 200? Are considered undesirable. Hang on. Dolly, you need to stop drinking. It's too loud. Okay. If a woman from the group was selected randomly, what's the probability that she would have an undesirable reading? So they're saying, what's the probability that she would be above 200? So if you look back up here, that's going to be between the 2 and 3 standard deviations and then beyond. So if I'm going to do those last chunks, I'm looking at the part here and here. So I'll be taking 2.35% and add it to 15.15, sorry. So you end up with a 2.5% probability of being in that section, where there was a 68% up here. So everything that we're doing today on day one is going to be just about figuring out how many of the chunks are you adding together? Like which part of the bell curve are they describing? So try not to let yourself get freaked out and make it harder than it is. All right, hope that helps. Bye.